Everyone knows dinosaurs were wiped out by an asteroid, except that's only part of the story. The asteroid wasn't the only thing happening. Earth was already changing before it arrived, and even after the impact, the dinosaurs didn't die instantly. So today we're going through every major reason scientists think dinosaurs disappeared, from the strongest evidence to the theories that probably aren't true. Were dinosaurs already struggling? As sea levels fell, shallow inland seas and coastal wetlands disappeared. These areas were home to many plants and animals that dinosaurs depended on for food. The changing coastlines also altered the climate, making some regions drier and others cooler. As habitats shrank and ecosystems changed, many dinosaur species had to compete harder for food and suitable places to live, making survival more difficult. Changing climate put dinosaurs under increasing stress long before the asteroid impact. Global temperatures shifted, rainfall patterns changed, and some areas became much drier, while others became cooler. These changes affected the types of plants that could grow, reduced food supplies, and forced dinosaurs to adapt, migrate, or compete for fewer resources, making many species more vulnerable. Scientists are still debating whether dinosaur populations were already declining before the asteroid struck. Some fossil studies suggest that certain groups were becoming less diverse because of climate change, volcanic activity, and habitat loss. Other studies argue that most dinosaur groups were still healthy and widespread until the asteroid impact caused their sudden extinction. Scientists still argue about this because the fossil record is incomplete. Fossils are rare, and many species were never preserved, making it difficult to know exactly how many dinosaurs existed at different times. Different researchers also use different methods to analyze the fossils, which can lead to different conclusions. As new fossils are discovered and better techniques are developed, scientists continue to test and refine their ideas. Chapter 2: The Deccan Volcanoes. So, Earth wasn't necessarily healthy before the asteroid. It may already have been under pressure. The Deccan Traps were a series of enormous volcanic eruptions in what is now Western India. These eruptions began around 66.4 million years ago and continued for hundreds of thousands of years, with some studies suggesting the most intense phase happened close to the time of the asteroid impact. Together, they released more than 1 million cubic kilometers of lava, creating one of the largest volcanic regions on Earth. Many scientists think these repeated eruptions gradually weakened ecosystems by causing unstable climates, habitat changes, and stress on plants and animals. Although the volcanoes alone may not have caused the mass extinction, they could have left many species less able to survive. When the asteroid struck, it may have been the final blow to ecosystems that were already under pressure from volcanic activity. Chapter 3: The Asteroid. Around 66 million years ago, an asteroid about 10-12 kilometers, 7.5 miles wide, slammed into Earth near what is now the Yucatan Peninsula in Mexico, forming the Chicxulub crater, which is about 180 kilometers, 110 miles wide. It struck at a speed of roughly 20 kilometers per second, about 72,000 kilometer arc, or 45,000 imop. The impact released an estimated 100 trillion tons of TNT worth of energy, billions of times more powerful than the atomic bomb dropped on Hiroshima. Because the asteroid struck in shallow water, enormous tsunamis, some hundreds of meters tall, near the impact zone, began racing across the oceans. Within minutes, millions of tons of pulverized rock and droplets of molten material had been thrown into space. Although many organisms had already died from the immediate effects, the greatest challenge was only beginning, as the enormous cloud of debris in the atmosphere would soon transform Earth's climate for months and years to come. Chapter 4: The Impact Winter. This is where most animals actually lost their chance of surviving. The asteroid's destruction did not end with the impact. It threw enormous amounts of dust, ash, soot, and vaporized rock high into the atmosphere, where these particles spread around the globe and blocked much of the sun's light for months to years. As the skies darkened, sunlight reaching Earth's surface dropped dramatically, Without enough sunlight, photosynthesis nearly stopped, causing many plants and forests to die. Since plants form the base of both land and ocean food chains, herbivores quickly ran out of food, followed by the carnivores that depended on them. In the oceans, the loss of tiny photosynthetic plankton disrupted entire marine ecosystems. At the same time, the lack of sunlight caused global temperatures to fall by an estimated 10-20 C, creating a much colder world. The combination of darkness, freezing temperatures, and collapsing food supplies turned Earth into an environment where most dinosaurs and many other species could no longer survive. Chapter 5. Everything else that followed. The asteroid triggered several other deadly events that made survival even harder. As sulfur released from the impact mixed with water in the atmosphere, it produced acid rain, which damaged forests, freshwater ecosystems, and soils. At the same time, glowing debris falling back through the atmosphere ignited wildfires across vast parts of the planet, destroying habitats and filling the air with even more smoke and soot. The impact also generated some of the most powerful earthquakes in Earth's history, estimated at magnitude 10 to 11, while tsunamis hundreds of meters tall near the impact site swept across the world's oceans, devastating coastlines. In the oceans, dissolved gases and debris contributed to ocean acidification, making it difficult for many shell-forming organisms to survive. Combined with the loss of sunlight, this caused marine food chains to collapse, beginning with microscopic plankton and spreading to fish, marine reptiles, and many other sea creatures. Together, these disasters created a chain reaction that affected nearly every ecosystem on Earth. Chapter 6. Why didn't every animal die? Although about 75% of all species went extinct, not every animal disappeared. Survival often depended on size, diet, habitat, and adaptability rather than strength. Crocodiles survived because they could live in rivers and lakes, eat almost anything, and go for months without food by slowing their metabolism. Turtles also benefited from living in freshwater environments and having flexible diets, allowing them to survive while ecosystems recovered. Small mammals made it through because many lived in underground burrows, were warm-blooded, and ate a wide variety of foods such as seeds, insects, and carrion. They needed far less food than giant dinosaurs and could adapt more easily to changing conditions. Some birds, which evolved from small feathered dinosaurs, survived because they were small, mobile, and many could eat seeds that remained available even after most plants had died. However, many bird groups also went extinct. Only a few lineages survived to become the birds we see today. The giant non-avian dinosaurs, on the other hand, were at a major disadvantage. Their enormous bodies required huge amounts of food, and many were highly specialized for particular habitats or diets. Once plants disappeared and food chains collapsed, they could not find enough energy to survive. Their large size, which had once been an advantage, became a fatal weakness in a world suddenly stripped of resources. In Chapter 7, the theories that didn't hold up. Over the years, scientists proposed several other explanations for the dinosaurs' extinction, but most are no longer supported by strong evidence. Disease is unlikely, because no known disease could have wiped out dinosaur species across the entire world, while sparing so many other animals. The idea that egg-eating mammals caused the extinction is also weak. Mammals had lived alongside dinosaurs for millions of years, so egg predation was nothing new. Some suggested changing oxygen levels, but geological evidence shows there was no major global drop in oxygen at the end of the Cretaceous. Still others blamed poisonous plants, but this cannot explain why marine animals and many unrelated species also went extinct. Finally, the second asteroid theory lacks convincing evidence. Scientists have found that the single Chicxulub asteroid is enough to explain the worldwide extinction event. So, what killed the dinosaurs? Not one thing. Volcanoes probably weakened the planet. Climate was already shifting. Then a 10-kilometer asteroid hit at exactly the wrong time. The impact didn't just create a crater, it changed the entire planet. And from that disaster came something unexpected. The world that eventually allowed mammals, and much later, us, to exist.